G, look at the question. Tera, 10 power plus 12. And pico, 10 power minus 12. So this is small p. Next question is, on the following list, underline all the units SI base unit, only the base unit, not the SI unit. So ampere and meter, that's it, only two. And the next is potential difference V between the two ends of the uniform metal wire is given by V is equal to 4 rho. Rho is the resistivity Li over pi d square. D is the diameter, I is the current, L is the length, low is the resistivity, and here is the percentage uncertainty table. And then the question is, the quantity listed in table 1.2 has a value. So this is the actual value of the resistivity. For this value, calculate the percentage uncertainty. So first look at this. We will write this formula in terms of the resistivity. So it is voltage pi d square divided by 4Li. So first we have to write this formula in terms of this rho, and then the percentage uncertainty of the rho is the percentage of volume, pi is constant, no uncertainty, plus 2 times percentage of diameter, plus 4 constant, percentage of length, plus percentage of current. Now from the table, volume percentage is 3.5 plus 2 times D, so 3 times 2, it becomes 6. Then the length percentage, it is 2.5. And then this I current percentage is 2. So when they are added, 6 plus 2, 8, 3.5 and 2.5, this is 6. I think it is 14%. So the answer for this value is 14%. Next part is the absolute uncertainty. So the absolute uncertainty in rho is equal to 14% of value of the rho, which is 4.1 into 10 power minus 7. 4.1 into 10 power minus 7 mean this is 14 divided by 100 multiplied by 4.1 into 10 power minus 7. So the answer is coming approximately 6 into 10 power minus 8. So we can write it either 6 into 10 power minus 8 or 6.0 into 10 power minus 8. So this is the uncertainty plus minus. So the question is define power. The only definition is work done per unit time taken by the object. Next, a car of the mass 1700 kilogram moves in a straight line along the slope that is at the angle theta to the horizontal. The car moves at a constant velocity for a distance of 25 from the point A to point B. Air resistance and friction provide the total resistive force 440 that opposes the motion of the car. For the movement of the car from A to B, state the change in kinetic energy. State mean no calculation. The answer is 0 because the speed from A to B is constant. Kinetic energy is constant. It's not changing. The change is 0. And the next, calculate the work done against the total resistive force. So the work is equal to F into D. The resistive force is given 440 and A to B, the distance covered is given 25. So after calculation, the answer is coming 1.1 into 10 power 4 Joule. This is the work done against friction. Now the next part is the movement of the car in B from A to B causes its gravitational potential energy to increase 4.8 10 power 4 joule. Calculate the increase in the vertical height of the car from A to B. So gravitational potential energy is equal to mgh. So 4.8 10 power 4 and the mass is given. It's 1700. So 1700 multiply by G value 9.81 multiply by height. So after calculation, H is equal to 4.8 10 power 4 divided by 1700 divided by 9.81. So it is approximately coming 2.9 meter. Next, the angle theta. So look, A to B slope is 25 meter. And the vertical height gain is calculated 2.9 meter. Now this angle is required. So this right angle triangle perpendicular over hypotenuse is sine theta. So first write the formula perpendicular over hypotenuse, then theta is equal to sine inverse 2.9 divided by 25, and after calculation, the answer is close to 6.7 degree. Now the next part is the last part, the engine of the car in B produces output power of 1.7 10 power 4 to move the car along the slope. Calculate the time taken. Look, the power formula is total work divided by total time. Now the total work is equal to total energy gained. So one of the energy is gained in the form of the potential energy, and the second, the work is done against friction divided by T. So the power is 1.7 into 10 power 4. The potential energy gained is given is 4.8 10 power 8. Sorry, 4.8 into 10 power 4, and the work done against the friction is 1.1 into 10 power 4. This is the total work done, one in gaining the potential energy, and other some energy is lost due to the heat friction. No change in kinetic energy, so that is not under the power. So time. So after calculation, the time will be equal to, the sum of these two will be 5.9 into 10 power 4 divided by 1.7 into 10 power 4, and the answer will be 3.5 seconds. So this is next question. Okay, next question. A child sits on the ground next to the remote control toy car. At time 0, the car begins to move in a straight line directly away from the child. So directly away from the child means the observed frequency formula is equal to Vf divided by V plus S, Vs. This is the observed frequency when the source is moving away from the observer. The car horn continuously emits sound of the frequency 925 between T0 and T6. The speed of the sound, this is the actual, instead of 330, 338 meter per second given. Describe qualitatively the variation, if any, in the frequency of the sound heard by the child that was emitted from the car horn from T0 to T2. So 0 to 2, the speed is increasing, and this is actually Vs, the speed of the car, source speed. So when Vs increases, this value becomes larger Hence, the frequency decreases. So answer is decreases. From T4 second to T6 second, from 4 to 6, this Vs is decreasing. So when this Vs decreases, the whole denominator decreases. It means F naught increases. So this increases. Next is determine the frequency to the three significant figures of sound heard by the child that was emitted. The same formula, F naught is equal to Vf divided by V plus Vs. So what is the actual speed? It is 338. What is the actual frequency? 925 divided by actual speed 338 plus at this instant 3 seconds, the speed of this is, I think it is 11 and 12. So we have to write here 12. Now after calculation, the answer is coming 893 hertz. Now the next part is determine the time taken for the sound emitted at T4. So first we have to calculate how much distance is covered by the toy car in 4 seconds. So we will move to the graph, and area under the graph till 4 seconds mean this area. And it's a trapezium 1 by 2, sum of the parallel sides. So this is 4 and this side is 2 and multiply by this height, which is 12. So this is 6 multiply by 12 divided by 2, so it's 36-meter distance is covered. So we will write here the distance is equal to speed into time. Distance is 36 and the speed actual is 338 time. So the time is 36 divided by 338. The answer will be 0.11 second. So this is the answer.